In this video, we're going to explore reactions of amines with nitrous acid, Part 2, the Tiffeneau Demjanov rearrangement. This is a reaction whose name is so mellifluous, I'm willing to suspend my distaste for people naming reactions after themselves just to have their names on them. As you can see in this reaction, you must start with a beta-amino alcohol. Typically, it's a cyclic structure. It does not have to be. Reaction with nitrous acid created when sodium nitrite reacts with HCl generates a diazonium ion, which we will see, that undergoes a rearrangement which gives a ring expansion by one carbon with the loss of nitrogen gas. This new carbon in the ring was the former beta carbon of the beta amino alcohol. The Tiffeneau Demjanov has such an elegant, stylish sounding name that it reminds me of maybe a special event you would want to go to. Like, honey, maybe tonight we should Tiffeneau Demjanov. So let's treat it that way. Just like going out on any good stylish date, you need to get ready first. So this would be my setup here, a little more straightforward than my partner. I'm going to start with cyclopentanone, react it with cyanide ion, and then hit it up with some HCl. And the mechanism goes as follows. Cyanide's a strong nucleophile. It's attracted to the carbonyl carbon. The pi breaks, becomes a lone pair on the O, creating an O-. O- protonates with HCl, generating our geminal cyanohydrin, depicted to the right. Geminal meaning both groups on the same carbon. Hydrin is old school for alcohol. Cyano is a cyanide group. The next question is, how do you reduce a nitrile to an amine? We've done that before in chapter 18. It's a reduction. You're replacing bonds from carbon to nitrogen with bonds to less electronegative hydrogen. And your first guess for reduction is typically hydrogen and platinum. So if I'm getting ready for my date, I'll spritz myself with some hydrogen gas in the presence of platinum metal, and we are ready to go. A slightly more involved setup for my significant other. We're going to take a nitro compound. Here, 2-nitropropane, which has a pKa of roughly 10. This is a strong testament to the electron withdrawing ability of the nitro group, which stabilizes this anion by both induction and resonance effects. This is simply an acid-base reaction, and I don't need much of a strong base. Hydroxide will do the job, and the mechanism is as follows. Hydroxide grabs the hydrogen, generating a lone pair on the carbon, giving us this anion right here. At this time, my date has picked up the phone and she's called Henri to pull the car up. We're going to do a nitroaldol reaction where that anion is attracted to the carbonyl, and we generate an oxide ion in the first part of the mechanism, and in the second step, which will be in blue, we will protonate the O-, giving us an OH. First step, attack the carbonyl. Second step, lone pair grabs the H from the solvent, creating a ethoxide ion. This is a nitroaldol or a Henry reaction, or Henry if you're American. Now the question is, how do you reduce a nitro to an NH2? I want you to look back into chapter 21, where this was covered. Possibly chapter 22. Let me get that information for you. In section 22.3 of your textbook, there are 4 ways listed to reduce a nitro to an NH2. It is a critical reaction you must learn, and you must know all 4 ways, because in the lab, typically the first method you try doesn't work, yet you must make it work. So tin reduction in HCl, where HCl provides protons and tin is a reducing agent, creates a beta amino alcohol here. So now we're ready for our date, the Tiffeneau Demjanov rearrangement. As seen in our previous video, nitride ion will react with excess aqueous hydrochloric acid, generating nitrous acid, which with the excess acid undergoes dehydration to the nitrosyl cation. Nitrosyl cation is a powerful aminophile. We have 2 amines that we created earlier in our setup steps. Let's look at them each reacting in a Tiffeneau Demjanov fashion. Looking at each of our beta amino alcohols, we can short form either one to RNH2. So we can start the mechanism the same for both setups. The amine attacks the nitrosyl cation, as we saw in our previous video, and the O becomes neutralized, generating this result. This N-nitroso-ammonium ion will then undergo tautomerization with HCl as the catalyst. The base form of the catalyst grabs a hydrogen. The sigma bond breaks and becomes a pi. And we protonate the O, giving this result here. This diazohydroxy species will undergo elimination to create an alkyl diazonium ion with this mechanism here. Lone pair grabs the H, sigma becomes pi, that'll be a triple bond, and water leaves when OH protonates, giving this result right here. This alkyl diazonium ion is special because there's a hydroxyl group as part of R, and we're going to see how that contributes towards forming a ketone. Finally, we see the Tiffeneau Demjanov rearrangement about to happen. Here's the diazonium, which resulted from my setup up here. Chloride's going to come, grab the hydroxyl hydrogen, sigma becoming pi, and the driving force of this reaction is to create nitrogen gas, highly entropy driven. Sigma here makes sigma here in the rearrangement, arrow right there, driving off nitrogen gas. This will result in the product shown right here, cyclohexanone. Clearly there's a new bond between 5 and 6, whereas before 5 was not bonded to 6. No more bond between 1 and 5, that became a bond between 5 and 6. Nitrogen gas is evolved. Let's look at what happens over here. 2 possibilities over here because it's not symmetrical on each side of the alcohol. On this one, we'll do the breaking of this bond to make a bond up here. And on this one, we'll break this bond to make a bond up here. Here's how the mechanism rolls. Both examples, chloride grabs the H. Sigma becomes pi. Old sigma breaks. Let's try it this way. Forcing off nitrogen. Same story over here. Old sigma breaks. Forcing off nitrogen. Giving these two results. And clearly my date knows the way to my heart is through a 7-membered ring, and she's accomplished 2 different versions. When 1 bond to 6 broke and made a bond from 6 to 7, this was the result. And when 1,2 bonds broke and made a bond from 2 to 7, this is the result. And that is the Tiffeneau Demjanov rearrangement step here. And I will give a summary of the overall for each reaction in these areas here before we leave. So looking at our overall reaction here, we made a cyanohydrin in the first 2 steps, reduced it to an amine in step 3. Diazotization followed by Tiffeneau Demjanov rearrangement gave cyclohexanone. We did a nitroaldol, also known as a Henry reaction in step 1 here, reducing a nitro compound to an amine in step 2, and the Tiffeneau Demjanov step in step 3 resulted in 2 cycloheptanones, thus ending our video on the Tiffeneau Demjanov rearrangement. I hope you have found it most educational, and I look forward to our next video.